Hey guys, Mr. Palmer here, back with part 2 of this Kb problem. We left off looking at this methylamine and calculating the concentration of the conjugate acid. In part C, it asks us to find a pH of our solution. And this takes one more step than it would take in a weak acid. First of all, you need to realize that what we solved for in the previous part, in part B, we found the concentration of the conjugate, which is all the concentration of the hydroxide. Okay, so we've already established this concentration, and finding the hydroxide concentration, right, it's the same as what we found in part B, 5.34 times 10 to the negative third. Right? If you didn't see that, go back and watch part 1. That'll help you out. And for us, we're looking to find the pH. Okay, so there's two things you can do. You can either get Kw and find the hydronium concentration from the hydroxide, or you can also take the hydroxide and find the pOH of that solution. Finding the pOH, we would just take the negative log of 5.34 times 10 to the negative third, right? And that would give us a pOH of, what would that be? 11.727. Okay. And that's going to give us, oh, I'm sorry, I got that one wrong. That's going to give us a pOH of 2.273. Sorry, guys. And when we add that, remember, pH plus pOH is 14. That's going to give us a pH of 11.727. And that should make sense because, I mean, this is going to be a basic solution where it needs to be above 7. I said conversely, you could take this concentration, find the hydronium concentration, and then substitute in this reaction. But either way, you should come out with the same thing. And you should also realize that 3 sig figs here, only the digits after the decimal are going to be significant. I would say that's like a 3-point part. I'd say 1 for knowing the hydroxide concentration, 1 for substituting in to get the pOH, and coming out to get the final pH of that solution. The last two parts of this, D and E, D says write the balanced chemical equation for the hydrolysis of the weak acid. Well, what was the weak acid, right? What was the conjugate that was formed in this methylamine hydrochloride in the first part? Well, CH3NH3 plus is that conjugate, right? It's that part of the methylamine chloride, right? If you add any conjugate to water, right, it's going to act like an acid. What's an acid do? It's going to donate its hydrogen, right? Its proton's going to come over here to water. That's what we talk about when we talk about hydrolysis. Give me CH3NH2. It's going to turn back into the methylamine, our weak base, plus H3O plus. Lastly, part E, I'd say that's just 1 point for writing the balanced equation. Part E says calculate the Ka of the weak acid based on the information in parts A to D. So the relationship you have to know here is that the Kw is equal to the Ka times the Kb for any acid and conjugate base, or any base and its conjugate acid. So that's going to be 1 times 10 to the negative 14th as our Kw. Okay, we're looking for the Ka. The Kb is 4.38 times 10 to the negative 5th. So we're going to divide, and that should give you a Ka of 2.28 times 10 to the negative 10. I'd say it's probably 2 points for this one, knowing this relationship, number 1, and correctly substituting and solving and getting the correct answer. Okay, so again, I would go back over and review this problem. It's a pretty straightforward one. I'd say it's worth about 10 points. You can go through each one of these, and if you have questions, comment, and I'll get back to you as soon as I can, or come see me for an explanation.